chapter 3, metals and non-metals. So in this chapter, part 2, we'll discuss about the occurrence of metal and how they are extracted. So we start with the part 2, occurrence of metals. Metals like gold, silver, platinum, they are found in free state in the earth crust because they are least reactive. They don't react with air, water easily, so that's why they are found in free states. And the metals from the middle reactivity series are generally found in oxides, carbonates, sulfides, halides form, and we will discuss all the three range of elements, their occurrence, how they occur in the nature, and how we'll extract them. So firstly, what are minerals? Minerals are elements or compounds which occur naturally inside the earth crust. And ore, it is a mineral which is used for extraction of metal profitably and easily. So there is a quote in the book also: all minerals are not ore, but all ores are minerals. So you have to remember this: the minerals which are used for extraction of metal easily and profitably are called as ores. Gangue. Gangues are the impurities which are left when an ore is extracted from the earth crust, and it is stick with the different particles like sand particles, clay particles, and when we wash it or do the different enrichment or activity, the left behind is known as gangue. So now we start with the extraction of metal from their ore. The different processes are: metals are extracted from their ore by the three main steps. These are: first, we have to do the concentration of ore. That means we have to enrich the ore. Enrichment of ore means that the ore should be having the metals in the compound form, not with the other impurities. Reduction of metal, then we have to reduce that particular metal from its oxide form to the pure metal. Then we have to refining of metal will be there. That means purification of metal we will do at the last to get the pure metal. So first, what is concentration of ore? It is a removal of gangue or impurities from the ore by different methods. Different steps which are involved for the extraction of metals, you can see from this flow chart. It is given in your NCERT also. We have divided the metals into three categories: highly reactive, medium reactive, and low reactive. The highly reactive metals are generally done by the electrolysis method. We directly heat the compound and it will be converted to its molten state. Then we will do electrolysis of that molten ore and we will get the pure metal. Medium reactivity, generally metals, they are found in two forms: carbonate and sulfide ores. And when we say carbonate and sulfide ores, actually these are the two forms in which these medium reactivity elements are found, and by the two processes, that is calcination and roasting. These are the two important processes we'll discuss in the next slides. These are used for the conversion of this carbonate ore and sulfide ore to the oxides of metals. Then by the process of reduction of metal, we convert that oxide to the pure metal, and at last we do the refining to get the purest metal from the particular ore. Low reactivity metals generally found in sulfide ore form, and we do the roasting process for the purpose. Remember that whenever the oxide ore are in oxide forms, then the reduction process is done directly. If it is in carbonate ore form, firstly by the process of calcination it will be reduced to oxide metal form. If it is in sulfide ore form, then by the process of roasting we do convert it to the oxide metal, and this is how it goes on. Now next we'll discuss about the extraction of metal which are low in the activity series or reactivity series. It is the same thing. The metals which are low in the reactivity series can be reduced by metals heating in the presence of oxygen. This presence of oxygen is actually along with high temperature we do, and this process is known as roasting. Like mercury is there. Mercury is obtained from its ore known as cinnabar, and it is in presence of oxygen with high temperature, when we heat it, it is converted to mercuric oxide. You can see from the equation, mercuric sulfide, when heated in presence of oxygen, it is converted to mercuric oxide and oxygen is released, and that mercuric oxide is again heated to get you the mercury and oxygen. So this is how we are getting the mercury. Copper is also obtained from its sulfide form, that is known as copper sulfide, in heating in presence of oxygen. When we are saying heating in presence of oxygen along with high temperature, that process is known as roasting. So this copper sulfide in presence of oxygen, when heated, it is giving a copper oxide. This reaction is not allowed to be completed. In between we stop reaction for some time, and then what will happen, the copper oxide and half of this copper sulfide will start reacting with each other. There is no need of further giving oxygen, and we'll be getting the copper and sulfur dioxide gas. Next is the extraction of metal in the middle of the activity series. In this, metals in the middle activity series like zinc, iron, lead are found, and these are found in oxide, sulfide or carbonate ore. It is easier to obtain the metals from the oxide, as I told you earlier also, because if the particular element is occurring in sulfide or carbonate ore, then also we have to convert it to the oxide form. So if the particular compound from which we are extracting a metal is found in the oxide ore, it is more beneficial for us. No oxides ore can be converted into oxides form by roasting or calcination, because calcination is used to convert carbonate ores into oxide form, and roasting is used to convert your sulfide ore into the oxide form. So what is roasting? Is heating an ore in presence of oxygen and high temperature, and it is used to convert sulfide ore into oxide form. Like you can say zinc sulfide, in presence of oxygen, zinc oxide will get. Calcination is heating an ore in the limited supply of air. This is the only difference, in that we are giving in presence of oxygen plus high temperature. Here that supply of air is limited, that air may be oxygen or small amount of oxygen. It is used to convert carbonate into oxide form. So this is the zinc carbonate converted to zinc oxide, and carbon dioxide gas will be released. Then these oxides which are reduced by the metal will be again reduced to the reducing agent help. That reducing agent we generally use is coke. Like zinc oxide we get, when we reduce it with carbon, we'll get zinc and carbon monoxide. Next is thermite reaction. A reaction in which the reactive metals like sodium, calcium, aluminiums are used as a reducing agent to obtain metals from their oxide. Here we, instead of using carbon as a reducing agent, we are using more reactive metals like sodium, calcium, aluminium for reduction purpose to get the metal from their oxide. And the manganese oxide here, along with aluminium, when reacted, we get manganese plus aluminium oxide plus heat. So it is a exothermic reaction. In this reaction, the reaction between metal oxides and aluminium is highly exothermic, and the metals are obtained in molten state. Such reactions are called thermite reaction. In this, what is happening, metal oxide and aluminium is highly exothermic reaction. You can see heat is being given out, and such reactions are called thermite reaction. This is very important reaction for the exam purpose, and you have to remember the uses also. This reaction between iron oxide and aluminium produce molten iron, and this reaction is used to join railway tracks, broken machine parts, heavy boilers, etc., in which the crack work, etc., occurs. You can see the reaction type. Iron oxide along with aluminium will give you aluminium oxide plus iron, and the heat will be released, and this exothermic reaction can be shown through this picture. You can see easily there was a crack on the railway track, and in this upper part you can see the reaction taking place. So much highly exothermic reaction it is that the molten iron will go downwards and fill the gaps. Next is extraction of metal at the top of the reactivity series. The metals which are top of the reactivity series, they are generally found in oxides forms, or we directly do the electrolytic reduction. That means we are not doing anything else. We just by heating we convert the particular into its molten state, and we pass the current. So when the current is passed through that particular substance, the different substance we get at the cathode and anode. We can take the example of sodium chloride. It is the best example. When the current is passed through the molten sodium chloride, you can see at cathode the sodium ion is getting one electron released from the chlorine, and the sodium metal will be formed, and at anode the chlorine will go and stick. Cathode is negatively charged and sodium ion is positively charged, so they will attract each other. Anode, which is positively charged, the chlorine is negative, they will attract each other. So we'll get chlorine gas on anode, and the cathode will get the sodium metal. You can see from the figure also that on the cathode the sodium ion plus electron, you are getting sodium metal. On anode, chlorine ion giving electrons free and chlorine gas is formed. So this is how the most reactive elements are refined. Now the middle and lower reactivity elements are also done made pure by the refining process, and the most common method of is electrolytic refining, because this is the best method we can get the pure particular metal. In this also the same process is there. Here we can take the example of copper. We have taken the copper, impure copper, as a anode part that we have obtained through this metallurgy process. Refining will be done of that particular copper, because it is still having some impurities, and pure copper which is already refined, we take a small rod of that pure copper to make it cathode. And this anode and cathode, you can see the difference, the color of the anode and cathode. The cathode is pure copper, completely brownish in color, and the impure copper is having the dark grayish in color because it is having the impurities. And the solution, we can take the copper sulfate solution, connecting it with the battery, and when you start passing the current, what will happen, the impure copper will start breaking down into copper ion. That copper ion comes to the solution, that copper sulfate solution having the copper itself break down into copper ion and sulfate ion, and those copper ion and sulfate ion will go and stick towards the your pure copper. So from here that your copper ions will be coming downwards, and these copper will stick to this. Slightly after some time, what you will see, that this size of this pure copper cathode will keep on increasing, and the size of this impure copper will keep on decreasing. And here at the bottom you will find that impurities will keep on increasing. These impurities will be the impurities which was present in the copper which we got from the refining process. So this final step, electrolytic refining, is the step to obtain the pure metal. Do you remember this? This is very much necessary for the middle and least reactivity series elements. Now last step is corrosion. So the corrosion is the damage caused to the metal due to the reaction of metals with oxygen, because of oxygen, moisture, or carbon dioxide. Formation of brown coating or rust over iron, you must have seen. If iron is left behind without coating any painting, it got a brown covering. Formation of green coating on copper, basic copper carbonate over copper. You have to remember that green coating, because 1 mark question generally comes. Okay, what is the basic copper coating green color is made up of? You have to remember copper carbonate. It is formation of copper carbonate. Formation of black coating of silver sulfide over silver, it is the AgS, you can say. Then to show that air and moisture are necessary for the rusting, we can take a activity for this. We have taken 3 test tubes, 1, 2, 3, and put it iron nail on each of them. Some anhydrous calcium chloride in test tube 1 to absorb moisture. In the second, we have put it boiled water and poured some oil over it, and then we have covered it. Third, we have put it some water and simply covered it, and we have left it for the few days. After some days, we will see that the nail in the test tube 3 is got rusted, and nail in 1 and 2 doesn't get rusted. Why? You can see from the next slide that in the next slide the pictures are shown that the nails in the test tube 1 and 2 are not rusted. So in the test tube 1, what is happening? In the test tube 1, you can see the air is said to be dry air. That means it is not having any water. The air in the test tube is not having any water. The water which was present in the air was absorbed by the calcium chloride. In the test tube 2, you can see the water is present, but we have boiled the water so that to get rid of the oxygen which is present in the water, and we have poured some oil so that outside air cannot enter the water. So the nail is only in touch with the water, not oxygen. In the third test tube, though we have covered it, but still it got rusted because the water is having oxygen inside, even the air which is present upward having oxygen. So the nail is getting both water and oxygen. So when both of these two things are got by the nail, it got rust. And if we have add some salt in that, sodium chloride, it will get even more faster. The rusting will get more faster. So you can see the salty water is most harmful for the your metal to get it rusted. Next is the prevention of corrosion. How you can prevent that, you all know. Corrosions of metal can be prevented by applying oil and grease, applying paint, by galvanizing, that means coating with zinc. You have seen the handles and your rims of the cycle. By tinning, coating with the tin. Electroplating, by making the use of electricity by anodizing. Next is by alloying, making alloys, mixture of different, we'll read next slides. So what are alloys? Alloys are actually is a homogeneous mixture of metals with other metals or non-metals. Like steel is when we mixed iron and copper. Stainless steel are iron, carbon, cobalt and nickel. Brass, copper and zinc. Bronze, copper and tin. Solder, lead and tin for use for soldering electrical wires. So if one of the metal in an alloy is mercury, it is called amalgam. This is very important. If any alloy is made and the one of the metal in that alloy is mercury, then that particular alloy will be called as amalgam. That means having mercury. Some pictures of alloys you can see from the daily life. These are the different steel products you are using. These are the bronze products we are in daily life. You are using medals and these springs, handles, bells, so all. And the brass, the different instruments of playing, like the this flute, etc. This trumpum, some watches, like etc. And the last table is showing you the different metals and alloys with their properties. You can see from this table, aluminium soft and brittle, alloy named duralumin is made. Metals in alloys are two, aluminium and copper. The property became harder. You see, when it was aluminium, the property was soft, but when we added some amount of copper in it, the property enhanced and it became hard. And now it is used for aircraft, racing bikes, etc. Likewise, iron, property weakness, brittle in nature. Aluminum, we have made steel. Traces of carbon, when we add it to more resistance to corrosion, and cars and ship it is used. Iron, again stainless steel, when we added along with iron, chromium and nickel, strong, very resistant to corrosion, surgical equipments. Tungsten steel, that means if we added the tungsten in it, very hard, high speed tools we can make it. Copper, bronze, copper, tin and zinc, stronger, resistant to corrosion. Propellers, खींचने की जो होते हैं चीज़ें. Soft, corrode easily, brass, copper and zinc. So from this table you can see the different metals when their properties or weakness is given, and when some other element is added to it, metal is added to it, the property changes and it becomes more useful. So this is how you complete your lessons. Thanks for watching this video. Do subscribe it. Thank you.